Very good morning to one and all. First of all, I want to thank Dr. Murli, different and his team in the university, especially ma'am. She is not here. She is my teacher. So I officially thank one and all. Actually, today I have planned for two sessions. One is on heterogeneity, serial correlation, and endogeneity in panel data. Another one is logic orbit model and fixed effect and graph model. So this session, I'm a little quick and fast. So if you have any problem, either you can stop and get it clarified. So first of all, I'm not going to teach the entire part. My concern on this discussion is only based on fixed effect and random effect model. That too, a very simple panel data model. I'm not going to talk about dynamic panel analysis. So only purely for simple panel data, right? Because all of you know that everything cannot be learned in one single session. I'm just going to give you. I'm just going to coin the idea. Okay. So from this, you can start your quick credentials on panel data. So I know that you would have learned everything, the basics of. Don't mind in going for points by points. So let me keep all the points here. So I know very well that Professor Kamya sir gave the basic lecture of about this. He is my teacher's teacher. Okay, so I'm his inclined. So still, I just want to keep this thing in my style because I don't know what he covered. So I know I'm 100% sure that he may taught you more, but I want to keep certain things. I want you to understand certain things. From that, I can very easy for me to continue my. So first thing is panel data. There may be a little confusion among people. What is the difference between panel data and longitudinal data? Technically talking, both are same. The whole name of panel data is longitudinal data. If you look at the tech literatures, empirical literatures, some people use longitudinal data, some people use panel data. We may always have the confusion. But technically, the whole name of panel data is longitudinal data. If somebody wants to explain what is panel data, you all know that we are collecting information about a particular entity over a period of time, right? I'm not going to discuss everything given here. Whatever I want to deliver, the points are given here. I'm going to talk. If you have any confusion, you can follow here. Okay, I'm not going to. Slides are just to make me remember the points in order, but I'm not going to talk everything here, right? Second thing is, as you know, generally when we talk about panel data, we talk about only individual units and time frames. Generally, panel data has 3 dimensions. We have to convert those 3 dimensions into 2 dimensions. From that only, we can go for our analysis. The 2-dimensional generally is in spatial, and the one is on time series, right? I think all of you know about what is spatial analysis or cross-sectional analysis, what is time series analysis. If you want to discuss about panel data, we are supposed to have some basic understandings about time series and cross-section. Then only it is nothing but a modified version of the combination of both. So we can't simply learn panel data alone. For this also we need some kind of understanding on time series analysis also.
Third dimension is variables.
Actually, the 2 dimensions. One is we having individual units here. Another one is in time. It may be in any frame also. We can go for time in this slide. So generally, what we used to do is we used to keep all our individual units on vertical dimension. Sorry, time is on vertical dimension and individual units on horizontal dimension. But it can be possible on this way also. If you use in that way, then you have to declare your model in such a way. So both the things are possible. What I'm saying is you can keep your time in horizontal also. Individual units in vertical also. If that is the case, then you have to define your models in a different way. The third dimension is nothing but the variables. We have to keep everything. This 3 dimension will convert into 2 dimension. Then we are using for it. It's a very basic thing. One equation is missing. Okay, because of this animation, something is missing here. Anyway. Generally, we can talk about panel data. It can be classified in different dimensions. One dimension is the type, what type of panel we are using. Basic panel may be micro panel, another one is macro panel. What is the difference between micro panel and macro panel? Even the second point. In the micro panel, generally, it will be collected only for a shorter period of time. Suppose if you want to go for, generally this kind of panel will happen in trade analysis. Suppose if you want to study about a trade of, even we can go for something like model. Generally, this happens in trade because if you deal with trade kind of data, the data is available only on annual data. It will not be available on monthly frequency or quarterly frequency. We have a very big frequency. So generally the observations are going to be very less. So in the micro panel, generally what happens is large samples with short time period. For example, you may have 5 years of data, but for 197 countries. This type of panel data is called as panel. Why we are very much concerned about all these things is all your results are based on what type of data you are using. Sometimes you may experience this. One person will get a better results with the same set of data, but you may not get it. All because of how the data was structured. Data is something different. Okay. I think all of you know about this since you are all learned scholars. Generally, the basic thing you have to understand before any data analysis, data will speak for themselves. This is the basic for all your analysis. Generally, what we used to do is we thought, not we in the sense, not I'm talking about not that conditions. Some people, those who are starting their career at the very beginning, what they used to do is they will learn some models. They will look some models in literature. They want to apply it for their own research. Okay. But out of 100 times, 95 times it won't work because it is the data which will tell you what type of model you're supposed to apply. It is not we who are supposed to design. Okay. So why the structures are important is sometimes some models may be applied for large data panel sets. But if you want to apply for a short panel, we have ended up with the problem. So the results, whatever you are going to generate, whatever you are going to estimate, is all depends upon your inputs. So the quality of inputs determine your outputs. So before going for any analysis, you have to understand the data structure and everything. So as I told you, questions. So in the micro panels, your number of observations is going to be very, very smaller than time series. Maybe you have micro panel. You're going?
No, sir. You can
Stand here, right? Okay. So if you have any confusion, the definition, you can take it from here. In micro panel, number of cross-sectional units is going to be much larger than the time period. Suppose you want to study the impact of COVID, all 120 countries, how much data will get? We'll get only for 4 years, not even 4 years, maybe 3 years. Okay. Then for 197 countries, the panel set is very high, but the time series is very less. So this kind of thing is going to be called as short panel. On the other hand, the condition number of observations is going to be less than time series. The trade analysis is going to be a long panel or time series. When we are operating on the long panel, macro panel, the time series effects will be very high. Whereas in the first case, the cross-sectional will have the dominant effect. So depends upon the data structure, only you can get the results. So you have to be very cautious about deciding the. So apart from that, there are one more data set, something called as balanced and unbalanced panel.
You told like, but depending on the structure, like we need to choose the methods. Like, isn't references that we can
see certain things we have to learn only by doing experience. Generally, what we used to do is we used to learn the techniques given in YouTube and other things. But the saddest part of that thing is those people who present the videos, they will pick the exact data, choose for the model. Okay, they don't have any errors. If you find any YouTube videos, do you come across any errors in that? The results will be fantastic. You can simply copy that and paste it. In that way only they will use the data. But once you started estimating your own data, then only you come across different issues. This you can learn only by doing.
Basically, we didn't try all the methods. And
yes, that is the best way for learning. Because we don't know. Because every data is a unique nature. Sometimes by luck, not by luck, maybe if you have the proper structure, it may fit well. But most of the cases, the data will teach you something. Then only we give the results. So we have to keep on digging it. We have to try the alternatives, all the possibilities, because I think all of you know, but economics is purely social science. It is not something where we have an exact relationship. Things may change even though if you add one more observations. If you add 1 unit of hydrogen and 2 units of oxygen, wherever you do it, whether it's a Bangalore or Hyderabad, you are going to get the same water only. The combination is going to be the same thing. But here it is not the case. If even one small change in the data will completely change the entire analysis itself. Suppose all your observations are in decimals, one observation is in hundreds, then if you're not notifying that, your results are gone. Okay. So it's very, very sensitive to the data. So we can learn these things by doing only. There are very basic things that I think all of you know about this, because since you are all PhD scholars, whatever data we're using, the first and foremost thing is you have to plot the data. Visualization will give you half of the story. By looking at the data itself, you can understand what type of information it wants to deliver to you, what type of model you can deal with that. It's very important. It's a very basic thing. Second thing you all know, descriptive statistics, right? Your plotting of the data, visualization, and descriptive statistics itself will tell you half of the story, right? If you enter any typos, then it can be identified in graphs as well as in what is that? The descriptive statistics. Same time, you can understand what is the variance of the data. Accordingly, you can choose a model. Generally, nowadays, nobody is doing that. Simply, we are started estimating the things, but that is not the best practice. Anyway. No? No. Second thing is balanced and unbalanced panel. I think all of you know about this structure. Balanced panel is something you are collecting all the informations for all the countries for all the periods. Unbalanced panel is a thing. There are some cross-section units are missing for certain period of time. I'm not giving any proper textbook definition. Whatever I'm giving you is maybe a definition, but what I'm delivering is just a layman's language. Okay. So this structure is also very, very important. Balanced and unbalanced panel. Certain models may not be suit well for balanced panel, or certain certain things may not be suit for unbalanced panel. So what is the solution? The solution is you have to stick on with the data which suits for it. But suppose you have an unbalanced panel, it's not working well, there is no other choice. You have to convert into balanced panel, then only you have to approach it. Okay. It's not in all the cases. In some cases, especially in trade cases, you can end up. Even one of our seniors is working on trade related issues. She has some data from 19. Suppose you take Indian data. India data is mostly we can get only of 1991. In China, the data is available from 1980s. For US, the data available from 100 years. So if you want to put it everything in one single thing, she didn't get any results. So you are forced to pick the data from 1991. So you are supposed to be open-ended. Okay, you are not supposed to be so adamant. You can't say that no, I will do only this. Then you never do that. Okay. So why I'm talking about all this thing? The structure is very, very important. Okay. Sometimes you may have a question: why one fellow is getting the results, why the other is not getting the results? Because of data structure what you are using. Actually, I start my discussion from this point on. So, why we are supposed to need panel data? Already we have a cross-sectional data. Already we have a time series data. What is the need for this? There are people who give this. There are a lot of people give a lot of definitions. These are the known economists in the field of panel data. I think Hassia, he wrote a book. Sometimes you check. The unfortunate thing is in panel data we don't have much books. So those books available is highly technical. Okay. Hassia is the one. Baldagi, I think everybody knows Baldagi. He is the one write a book on panel data. Okay. If you talk about Econometrics book, Gujaratis, people used to call it as Bible. But in panel data, this thing is very limited. Andres is there. So these are the people who give a lot of advantages of using panel data instead of few cross-sectional observations or instead of few time series observations. Obviously, you know that you have a multi-dimensional thing. If you're going for cross-section, you have only vertical analysis. You have a time series, you have only vertical analysis. But here we have n cross-section, which will get you t times this, and the combination will give you more observations. The dimension is very high. You have more information, right? Second thing is, if you have more observations in such a dimension, then you have the information content of the data is more. It is going to be more informative. It is also not only it's going to be, there are the positive sides, there may be also negative sides also there. The negative side may be the more variable. The data is going to be more variable because you are putting everything in one bowl. Okay. Okay, we are going to discuss that part only. The other serious problem is less collinearity. I think all of you know about what is multicollinearity. So if you have such a multi-dimensional data set, then it will lead to it reduce the problem of collinearity problem. Another important thing is, if you want to do any research, there is a condition called as degrees of freedom. I think you all know what is the degrees of freedom. What is degrees of freedom? The number of observations must be always greater than number of equations estimated. If you have such a huge data set, then degrees of freedom may be avoided. If you have such a data set, this is the very basic thing. The second thing is, it will help you to understand how the dynamics are happening. Okay. If you know only one dimensional set of data with less observations. Suppose if I want to study about growth rate of a particular country for 10 years, yes, you will get some results. But the same thing, if you want to study for 100 years, results are going to be something different. So it will give you multi-dimensional approach of everything, which is not possible in pure cross-sectional as time series data. Finally, important point is this panel data will control for individual and time heterogeneity. From this only we are going to talk about my discussion starts. Okay. So what is heterogeneity? That is a question. If you look at that point, we have two things. One is individual, another one is time. So what it means, there may be heterogeneity in cross-sectional observations. There may be heterogeneity in time series observations. Both of the things can be taken care by panel data analysis, right? So just keep this point in mind. Okay, concept of heterogeneity. So if you want to know about heterogeneity, then you have to know the concept of endogeneity. Okay. Let me finish this, then I can talk. So what is heterogeneity? Heterogeneity in panel data, whenever we are using this concept explains that there's a unique nature for every cross-sectional observation. Okay. There may be a unique nature for each and every cross-sectional observation we are using in this set, which is time invariant. Okay. I'll come to that point. What does heterogeneity means? There may be a unique nature, unique characteristics, okay, a specific characteristics for the times cross-sectional unit, what you're using in this thing, but it may differ from each other. For example, if you take the cultural pattern of India, if you compare the cultural pattern of India with some of the country in Africa, there may be huge difference, right? So even though within the country we have a cultural difference among the South Indians and North Indians, maybe even the cultural difference happens between the South Indian itself. So if you want to compare all these things, if you're studying, for example, if you want to study about fooding habits of Indian states, all 27 states, then each and every state have the unique pattern, right? Generally, we South Indians, maybe we used to take more rice, right? Maybe North Indians, they have a different pattern. Even in South Indians, Karnataka people have the different pattern of having breakfast, and Tamil Nadu people have the different habit of taking breakfast. Keralans, you know, they go for food and the other parts of things. So there is a huge difference. So what this heterogeneity says is that each and every cross-sectional observations we are using in our panel structure have unique characteristics, but which differ from each other. Okay, so that is the thing. So if you want to understand that, you can take the second point: differences across individuals, which is very, very important for your empirical analysis. Suppose you want to study about the food consumption pattern of Indian states. If you're not including their cultural background, then whatever results you are going to get is going to be, you can't simply say that the entire India is consuming only rice. Okay, the culture matters, right? Whenever we talk about heterogeneity, what is that? It is nothing but the unique nature. There are two things. You can classify heterogeneity into two things. One is it may be observed heterogeneity, it may be unobserved heterogeneity. The heterogeneity may be time varying, heterogeneity may be the same time, it may be time invariant also. What is observed heterogeneity? Observed heterogeneity, you can easily observe. You are able to understand. Okay, you are able to, suppose if you want to understand an income of a people, what determines income? There is a lot of factors on working experience, education, so and so. These information you can easily observe. Apart from that, the person's IQ level, okay, cultural background, family setup, his parents' education, the schooling, these factors are there, which you cannot observe. But still, those factors are influencing your, you're getting the point. Certain factors are there, certain unique characteristics are there, which is not measurable, which is not directly observable. Okay, but that is also having an impact on determining how I'm behaving. Right? In our food consumption of states, example, the cultural pattern is very, very important. Okay, each factor is important. Certain factors, the interesting part is that factor won't change. That factor won't change with respect to time. It is time invariant. It is constant, or your IQ level is not going to be changed for your entire lifetime. The languages you know is not going to be changed for an entire lifetime, right? I may know only 3 languages, somebody know maybe 6 languages. That influence my entering of job markets also, right? The languages you know, your analytical skills, okay? Everything matters, your body language, everything matters here. But this has, it's not same for all, right? In this classroom, there are 20 people out there. Somebody know 6 languages, even who knows? Somebody may know only 1 language, maybe 2 languages. So how many languages you are knowing has a impact on your employment opportunities. You are very good in German and French getting into system is very quick, especially in IT, right? So that is unique character, but that influencing their opportunity of entering into the system, it won't change. If you know German this year, next year you're not going to forget, right? It's going to be constant. It has a continuous impact on your job opportunities. So these are the definitions. If you want to know, have some examples for observed heterogeneity, age, you can observe age. Age is going to be change every year, right? It's not going to be time invariant. I'm not going to ask your age, don't worry. So income, sometimes also income is also going to change, right? Gender we can observe, right? Education sector, this is all nothing but your observed heterogeneity. If you want to understand unobserved heterogeneity, maybe the price of the product is determined by not only the quality, it also depends upon how much they are spending for R&D. There may be some 6 or 7 companies. Take an example of mobile phones, laptops. Why certain mobile phones are costlier, certain mobile phones are somehow cheaper? Why certain laptops costlier, while certain laptops are cheaper? All because of how much that company is spending on their marketing, research and development, their sales on top. Okay, even the marketing will differ country to country. The spending on marketing will differ country to country. So those things are you can't measure how much a company is spending for R&D. It's not even in the public space. Maybe it won't be circulated among the group of people. Maybe culture is the best example. Culture is there. Okay, it is a unique nature of individuals. It won't change, but it influences your decision making. So these are some of the classifications of heterogeneity. So whenever in this discussion, in the entire discussion, we are going to talk about only unobserved heterogeneity, not observed heterogeneity, because it is the one which we are not able to capture. It is the one which we are not able to compute, but still it has an impact. It's a kind of gray thing. Okay. Even we can call it as like air. Air is there. We are not going to see it. Okay, but we can feel it, but still it influencing our survival. Like that, we can unobserved heterogeneity, maybe air may be the best example, just for a funny thing I'm saying. Okay. So why, when in this entire discussion, we are going to talk about only unobserved heterogeneity. Okay, which is time invariant. Just keep in mind, your heterogeneity, which is unobserved, is going to be time invariant. If it's time variant, then you can easily observe, right? So why it is matters? Here, maybe I can use board, maybe if it's required.
Why we are not talking about observed one?
See, observed one is known to all. We are always bothered about something which is concern us, which is uncertain, right? Which you are not able to capture. Okay. Why you are going for soothsayers? Why you are going for astrologers? You always want to know about the future, not the past. If you know, you are not going to, the astrologer is not going to tell you what you are going to be in today, because you know itself, right? Why you are bothering about it? You know only what's going to happen in future. You always bother about future. Unobserved thing is matters here. Here, why we are talking about unobserved thing is we don't know about it, but still it's influencing it. But observed thing, I know. If my education determines my earnings, if I ask you what is your education qualification, from that I can easily understand how, if you're this is a myth, I'm not very sure about it. Even I'm not accepting this. Highly educated means you can earn more. That is a general acceptance, right? Universally accepted thing. There may be different opinions, but universally we accept that a person who is highly educated will get more income. But you don't know his cultural background. Maybe that fellow may be highly educated, but still he has a cultural background from a traditional business family. That is influencing his income. So anyway, this thing I supposed to start somewhere. Anyway, I will start here itself. Why this unobserved heterogeneity matters is because we have a problem, some problem called as omitted variable bias, right? Anyway, whatever regression you are using, no, is the correct thing. Okay, anyway, just keep in this mind. Maybe I can explain this later. So why we are talking much about unobserved heterogeneity is, if you are not including that, if you are not taking care of it, it will lead to the problem of omitted variable bias. What is meant by omitted variable bias? There is some variable which is influencing your decision making, but you are not incorporating those variables in your model. So what happened? The impact of that particular variable will be replicated in your error term. Because of that, the estimates what you are going to obtain from the model is not reliable. I think this basic part you know. In any regression analysis, we have a set of conditions. I'm talking about, maybe I can confine myself. I'm talking about simple OLS method, where we are using 2 observations or more than 2 observations. If you want to estimate the parameters of this OLS regression model, you are supposed to follow a set of conditions called as order least square method or classical linear regression model assumptions. In that set of assumptions, certain assumptions talks about the conditions of the error term. Certain assumptions talks about how the variables of that model is supposed to be integrated with each other. The certain assumptions talks about how the error term and the independent variables are supposed to be integrated. Okay, this is the issue of heterogeneity. Heterogeneity. If you're estimating a model, you get the coefficients. How can you check the goodness of the fit of the model? I'll give you some data. I'll ask you to estimate some. All of you get you estimate some results and you come up with some estimated coefficients. Suppose let us take 10 people. I'll give you 10 set of data on income and consumption. You give me otherwise I can tell you in this way. I ask you to collect the income and consumption data among all of yourself. So each one of you have some 20 observations, each one of you. So I ask you to estimate the consumption and income data. I want to check what is the model supposed to consume. All 20 will come with different results, right? So which model I will choose? On what criteria I was supposed to choose to pick the model? I can't go with all the 20 models, right? I have to pick only one from that. So what is the criteria? It is nothing but the goodness of the fit. There are a lot of criteria out there. One important criteria is the error of that model must be as minimum as possible. The purpose of OLS is minimizing the error, right? How do we know the errors, estimated errors is very less? For that, we have different criteria like R square, F stat, so and so. What I'm trying to say is that the error must be minimum as possible. But in this case, if you are not incorporating the correct model, you all know that consumption is not only the function of income, it is also depends upon prices. Not only prices, taste and preferences. Apart from there are a lot of sentiments out there. I think all of you may have this thing. You don't know which color of car is least sold around the globe. One color of car is people won't buy. If you plot the entire car purchasing, one particular color of car will not sold out. You know which color? Anybody? Green color. Why? Because in the night time, if you're traveling the highways, the green color won't be visible to the person who is traveling in front of him. That's what around the globe, green color cars are sold out less. If you're not taking this factor into account, if you model this, what happened? The impact of this color will replicate in your error term. So the error impact is going to be very high. You can't rely on this model. So why we are talking about heterogeneity? Heterogeneity is something is a unique character which is influencing your decision making, but you are not including this in the model. Then what happened? The impact of error will be increasing. So your entire model is going to be, the estimates what you are getting from the entire model is questionable. It is not unbiased. It is biased and inconsistent. So if you leave the heterogeneity, if you are not incorporating heterogeneity in the model, then you will end up with something called as omitted variable bias. What it means, if you omitted a variable from the model, it will create the bias in your estimated coefficients. So that is one of the problem. What are the results of omitted variable bias? It will lead to incorrect conclusions. Based on this, you can't conclude. If you conclude something, that is going to be wrong, right? That the validity of that conclusion is questionable. Second thing is, as I told you, biased and inconsistent estimates. What is the ultimate purpose of doing any analysis? You want to estimate the slope and intercept. Okay. If you estimate a model with omitted variable bias, then those estimates are going to be biased and inconsistent. Finally, this is the thing. The assumption of this assumption is called as errors in variable in a classical linear regression model. What is assumes that the error term is not supposed to be associated with the independent variables. Okay. There are 11 or 12 assumptions are in the classical linear regression model. Certain books give even 13 or 14, but the core assumptions are 4. This assumption of homoscedasticity, another one is assumption of serial correlation, another one is multicollinearity if you're dealing with more than 2 variables. Finally, errors in variable. Errors in variable in the sense your explanatory variable, that is independent variable, is not supposed to be associated with the error term. If you are doing so, then the problem of simultaneous omitted variable bias will happen. So if you leave the heterogeneity, if you are not including that unobserved heterogeneity in the model, then you are going to end up with all the. So how can we do this? So if that is the case, how can we accommodate this in the panel model? The fundamental advantage of panel model is that it is has the ability to control this, individual specific unobserved heterogeneity. Okay, the model itself is designed for that purpose. So we are going to discuss in this way only. Your simple cross-sectional observations as well as your time series won't capture this. Okay, this is the thing. So there are different ways are available in panel models to accommodate heterogeneity. It depends upon nature and structure of the unobserved factors. So sometimes the unobserved heterogeneity you are not able to capture because this model matters depends upon the structure of your data. We discussed about micro panel, macro panel, balanced and unbalanced. Depends upon the data, this thing will change. But okay, before moving to the models which are there to capture the heterogeneity problem, let us talk about few basic things. If we talk about panel data models, what type of models do you know? I think you might have studied this. Generally, we start with certain set of simple panel model I'm talking. If I ask you those models, these are the things you can come across, right? All the panel models can be classified into any one of these things. Let me finish this, then I can come. There are two different set of panel models are available. Not two. We can classify the existing panel models into two different sets. One is homogeneous panel model, another one is heterogeneous panel model. What is homogeneous panel model? It is also called as pooled panel data model. The simple idea is the parameters, the estimated parameters of the homogeneous panel model is same for all the observations what you are using. Whereas in heterogeneous panel model, there may be a cross-sectional heterogeneity existing among the panels. So I can explain this model. If you look at this model, I can explain with the next equation. Look at this equation. This is a very simple basic equation. We don't have anything. We have y, a dependent variable, is a function of, I'm not talking about int because you know this is the panel data structure. A simple panel structure is a function of a constant plus beta, HIT, plus EIT. If you look at this, both the dependent variable is having int, independent variable is int, even the error term is int, but the constant, which is not having int, what it means? This constant is going to be same for whether you are using Tamil Nadu, whether you're using Kerala, whether you're using Karnataka, whatever it may be, this constant is same for all the states. It's not going to be changed. It's going to be similar. I'm not typing this equation here because it's very tough. Using math type here, then copying and pasting is very hectic. So I just cropped it from some other sources. But the idea is this. So if you want to understand this properly, if you look at the second equation, you can easily catch up. Just remember this. We have a dependent variable, which is in the panel structure where int is there, cross-sectional unit and time series unit is there. It's a function of a constant, which is not time varying or homogeneous, does not have any heterogeneity, whereas the independent variable is also having time and spatial coefficients. Error term is also there. So if you look at this, the constant is same for all. So in other words, we can say that all the cross-sectional units, they are the same constant for over a period of time. In technical terms, you want to make it very clear. This last point will help you. This constant will tell you all the cross-sectional units are sharing only the common coefficients of the regressor. Okay, right? But there are separate group specific intercepts for that. But the intercept is time varying. Intercept is specific. Suppose I'll tell you in this way. Suppose if you want to study about consumption pattern of among the countries. Yeah, there may be India, there may be, let us assume South Asian countries. There may be 4 or 5 countries. That constant is talk about they're all humans. Yeah, that won't change. Whether you're not going to collect data from non-human being in some other country. So it's going to be human. I'm just a very awkward example, but you can connect this. But whereas if you have that constant is going to be common for all, but when you come to country I may be India, country J may be Pakistan, country K may be some other country. It's also going to be time varying. Okay. So the idea is all the cross-sectional units are going to share the common intercept. Okay. Whereas, sorry, all the cross-sectional observations are going to share the common slope, whereas they may have the group-specific intercepts, which means that for each and every state, that intercept may change, right? So look at this second equation. What is the difference between first equation and second equation?
Constant.
Yes. In this thing, the constant is group-specific. Okay. For India, we have a different constant. For Pakistan, we have a different constant. For Bangladesh, we have a different constant. So comparing these two models will give you what is homogeneous model and heterogeneous. The first one is homogeneous model, panel model. And we assume that the parameters are common across all individuals. Whereas the second thing, parameters not only the constant, the other parameters also group specific. If the group is changing, then the constant is also changing. This kind of model is called as heterogeneous panel models. So what are the common homogeneous panel models and what are the common heterogeneous models we know? Okay. This is what I already told about this thing. We'll talk about the equation first. Remember this equation actually. I want you to remember this equation. So what happened is you easily classify this. The first set of model is homogeneous model. The second set of model is called as heterogeneous model. So what is going to be the case if we have individual specific panel data set? Let me show you this equation. If you understand the equation, the rest of the part is simple. Okay. So what is the case here? Here we have a dependent variable which is in a panel structure. We have a independent variable also which is panel structure, and we have a coefficient delta ZIT, right? So look at this model here. We are not including constant for the sake of simplicity. I'm not including constant here. So you know the structure, right? HIT is nothing but IT is supposed to be in the subscript. Because of copying from Word, it's lost its thing. But don't copy this. It's supposed to be in subscript. HIT. This thing I'm talking. It is supposed to be in. Okay. The typo. Actually, the entire slides are like that only because I typed in Word and copied and paste here. So making these things is very tough. So just keep on remembering those things are subscripts. So it is nothing but a vector of variables. Okay, x is nothing but one single variable. It may be 1, 2, x1, x2, x3, x4, something like that. So the point here is we are talking about heterogeneity, right? We are not including constant, but still we have a delta ZIT. Right? This is not a constant. It is individual specific characteristics. Example, take an example of state spendings, okay, or health status of Indian states. Okay, if you document the health status of Indian states, then that delta ZI is nothing but state specific indicator. Okay, if you take Tamil Nadu, in Tamil Nadu, all the districts have minimum one medical college. 36 districts are there, 29 districts are there, minimum one medical college, maximum two to three medical colleges are there. So if you take Arunachal Pradesh or Assam, you are not going to get the same structure. You are taking Jharkhand, you are not going to get the same structure. So this delta ZIT is nothing but the state-specific, individual-specific effects, right? Is it clear? So if you have such a model, if that individual-specific effect is observed, if everybody knows that, okay, if I told you that Tamil Nadu has so much of medical colleges, if you know that it is observed one, you know that that has an impact on this. Observed heterogeneity doesn't matter. What matters here is only the unobserved heterogeneity. So the same thing, health status, if you compare with education, Tamil Nadu GE are more than higher than the national level. Okay, so how people are using the medical facilities, if you are using medical facilities as a function of so-and-so variable, one among the variables is education. Okay, education status also important. But in this case, if you are not able to capture the education, you don't know what is the education status of people in Tamil Nadu, right? Almost 12 crores people are there. But still it influencing their turnaround to the medical hospitals, right? Which cannot be observed. So the point here is, if the heterogeneity is observed, we don't have any problem. We can use it. But if it is not observed, then we have to model it, right? If you leave that part in your model, that effects are going to be replicated in your error term, then the estimates are going to be problematic. Are you getting the point? Here, I can make it in a very simple way. We have something called as heterogeneity, right? What is that? It is nothing but the unique characteristic of a specific individual, right? It may be known or it may be unknown. Still, it's influencing your decision making. In your model, if you have a heterogeneous variable, which is observed to everyone, then it doesn't matter. Okay, everyone needs an observed heterogeneity. If you have something which is unobserved, you are not going to include in the model, but that unobserved component which you are not including in your variable, the impact of those things will be replicated in your error term. Then the estimates what you are going to be biased and inconsistent. Okay, that's what I am saying. If this delta is group specific variable, it may be observed, doesn't matter. It may be race, sex, location, and dot. It may be instead of sex, it may be gender anyway. Is gender and location, it's fine. We know that that is the known factor. The second thing, suppose if it is not observed, it is unobserved, it is only a group specific characteristics, then if you're not including it, then whatever you're estimating, it's going to be a problem. So if you have some unobserved heterogeneity, then you can't estimate that help of ordinary least square model. If you're doing so because of omitted variable bias, then you are going to end up the problem. Are you getting my point? I'll make it in a very simple way. Maybe a quick revision. We have something called as heterogeneity. What is name heterogeneity? Heterogeneity is a problem arise if the excluded variable have associated with your error term. Okay. If there are some variable which is included in the model, but it still have the influence with the error term, then you have the problem of exogeneity. This is one condition. Second condition is there may be some variables which is influencing your dependent variable, but you are not including those variables in your model. If you leave that model and estimate the regressions, the effect of excluded variable may be replicated in the error term. So the estimates what you are going to get is going to be problematic. It's going to be biased. I think you got the point. The third thing is, what is that variable? It is called as case specific or individual specific characteristics. Okay, individual characteristics. If the characteristic is known to all, then we can incorporate it, doesn't matter. Okay. If the characteristic is not known to all, but you are not incorporating it, then it will replicate in your error term. If the heterogeneity, that individual unique characteristics not measurable, it is not unobserved, then you can't, but still it has an impact on your decision making, still adds through with error term. You can't use simple linear regression model for estimation purpose. We have different set of models for this estimations. What are those? What I'm saying, if the Zi, that is this coefficient, is unobserved, then you have a problem. You can't run simple linear OLS model. In most of the cases, it's unobserved only. Can anybody tell me what are the factors determining your demand?
Yes.
The law of demand says that people will buy more at less prices and buy less at higher prices. Other thing remains constant. Then what else?
Income,
Income,
taste and preference.
taste and preferences,
Availability.
availability,
Related goods.
goods,
Complementary goods.
Health.
complementary. That's all. Weather, fantastic. If I keep on asking you, if I ask you what are the factors determining your demand, each one of you come with different answers, right? So nobody can say that which are the factors exactly determining your demand. There may be 100 people, there may be 1,000 variables, right? So the point is, in most of the cases, you can't observe everything. I'm talking about this case. Then you may ask a question, sir, then how can we fix the demand function? The other point is, out of lakhs and lakhs of factors, maybe some 6 or 7 factors causing demand by 98 or 99%. Remaining lakhs and lakhs of factors will cause only by 1%. So we leave that. If you leave that factor, the impact of error term is going to be very less. Right? So as I told you, we can't go for one-to-one relationship. It is not a laboratory science. Okay, 1 + 1 is equal to 1 is not possible here. We are always having some kind of error. The ultimate purpose is we have to fit a model which is as having minimum error as possible. That is our objective, right? So in most of the cases, we end up with delta is going to be unobserved. So in that case, we can't apply our simple OLS for our estimation purpose. So what is the solution? These are the solutions. Generally, there are 4 popular models are there, but I'm not going to discuss all. Maybe I can give the quick revision because you have to move on to some of the. My thing is not only this, I have to cover about your serial correlation as well as the other part also. So these are some of the methods are available in panel data to address heterogeneity problem. Two things you know, I think, pooled order least square method. It is also called as p-less model. The second one is fixed effect model. The third one is random effect model. Final one is, I don't know how many of you are aware of this, random coefficients or random parameters model. So these are some of the models I'm not talking about only these models. These are some of the famous methods are available to deal with the problem of unobserved heterogeneity, right? So what is pooled method? That equation is supposed to be here because of something it missed. Anyway, you can take in the next way. Forget about everything. The basic idea of pooled OLS is the first one. It ignores heterogeneity. It never take about heterogeneity. It assumes that all our unobserved heterogeneity is going to be constant for all. Doesn't matter. Okay. So that's the first thing. The pooled OLS, I just gave the what to say, one-line story of this, the beginning itself. Maybe you can follow it. The first thing is it says that it assumes that heterogeneity is common for all. There is no individual, unique, specific characteristics. It's common for all. Okay. In that case, if heterogeneity is common for all, there is no need to observe. If you have something special, okay, your IQ level is close to 140, then only you are supposed to monitor. If everybody has the same IQ level, then there is no need to worry about it. So if there is no any individual specific unobserved heterogeneity, then your model is going to be simply like simple regression model with a panel data setup. Is it clear? There is nothing here. Your alpha is common for all. This is what first we saw, right? The same equation. So this implies that there is no dependence within the individual groups. There is no groups. The panel data can be treated as one large pool data set. It's just going to be a pooled regression. Nothing is there. There is no differential among the states. It's all common. Okay, we are all Indians. That's all. There is no state specific or what to say, regional specific indicators. Right. This is the case. You can directly estimate your pooled regression without considering anything. But the problem here is but as I told you, out of 100 times, majority of the times you end up with heterogeneity. But what we are doing is we assume that there is no heterogeneity and estimate the model. So those models are not reliable in nature. So what is the solution? As I told you, there are different models for that. The first one is pooled OLS. Second one is fixed effect model. I think you would have a lecture on fixed effect model and all. I'm not going to take much time. Maybe I can make it very quickly. If the model, if you have the unobserved heterogeneity, yeah, the best, if you want, you have the problem of unobserved heterogeneity, the best model to deal with is fixed effect model. Fixed effect model will deal unobserved heterogeneity a better way than random effect model also, right? What it do is it controls both time invariant unobserved factors as well as positive factor. I'm talking about the second thing, right? So what I gave here, because if I talk something which is not relevant here, then it's maybe a problem. Okay, this is the point I want to tell you. Fixed effect model will control the time invariant unobserved heterogeneity. Just keeping this word in mind. What is that? Unobserved heterogeneity. That is individual case specific, which cannot be captured, but it is time invariant. So how fixed effect model will deal with this is it will give each and it will give each respondent, each cross-sectional unit a separate intercept. Look at here, like this. It will give a separate cross-sectional individual specific here. Yeah. If you are doing so, it is observed that this coefficient. What is this? This is nothing but your unobserved heterogeneity, which will not correlate with your error term. Right? So if you are what is the problem here? The problem here is errors in variable. That is nothing but your unobserved variable is correlated with your error term. If it is not happening, then the model is well fit, right? According to this fixed effect model setup, if you separate true specific identity for each and every variable, it gives a separate individual characteristics for each and every state or something. So that will help you to avoid the problem of omitted variable bias, right? thing is, I told you how fixed effects will deal, but how it solve the problem? That's the question. We have a fixed, as I told you, that's a fixed effect. That's a problem of heterogeneity. Fixed effects will deal with that. Pooled OLS will not be the solution. How this can be handled? Actually, if you want to solve fixed effects, this heterogeneity problem, there are these methods of that. One is first difference method. I don't know whether I gave the equations or what. There are some methods are there to solve the problem of heterogeneity in fixed effect model. The first one is first difference method. First difference method you all know. In time series, you know there is a called a stationary, right? What is stationary? What is the condition of stationary? When can you define a variable as stationary?
It is mean reverting.
Exactly. If the variable has mean reverting process, the best example is the electrocardiogram. If the variable is mean reverting, then it is called as stationary. If the variable is not mean reverting, then what you used to do? We make it stationary by taking the first difference. The same logic apply here. If you have a variable, there are some equations. I'm not showing the equation. I'm just coining with the idea. So how can you solve this fixed effect model, unobserved heterogeneity problem on fixed effects? You can apply first difference estimation. Data itself will compute the first difference. If you estimate the first difference, then the problem of heterogeneity will be solved. Right. Second thing is within group.
Won't that alpha I get eliminated when we take first difference?
For that, I have to show you some huge. Different. Maybe after this thing, I can show you some data. It's if you look at the data with the naked eye, you can easily understand. This is the process. How to see? Maybe in time series, you can easily understand. If you take two difference between the two data points, the distance will come down. So the distance is going to be very minimal. So it may not deviate much. Like that, if you take the first, there is a lot of literature on that. I'm telling you what the procedure. If you want to know each and everything, then itself is take a separate thing. Maybe I can show you some. First difference, if you take the first difference of the estimates, then you can leave the problem of what is that? Heterogeneity. You can group transformation of the data, something like log transformation and all. The final thing is least-square dummy variable, LSDV. I think you know this. This is nothing but the modified version of fixed effect model. You have to give dummy for each and every observations. I think those who talk about fixed effect model, they might have covered this. Instead of going this, suppose you have 27 states, you have to give 27 dummies. But that is not advisable because if you're keeping so much of dummy variables, LSDV is not always the advisable model because if you keep on giving so much of dummies, then you have the problem of degrees of freedom. You're going to lose degrees of freedom. The condition of number of variables must be greater than number of observations will be violated. If you look at the thing, the first two techniques focus on eliminating the individual effects. It's try to remove the what is that? Heterogeneity from the model. Whereas the final thing, it's try to model it. It's try to incorporate it through this thing, dummy variables, LSDV models, right? Okay, maybe this point. See, look at the first. This is the thing you have to remember. The fixed effects try to control the time invariant coefficients. The first thing is the pooled regression. It just simply assume that I told you right. Pooled regression simply assume that all the coefficients are constant. Whereas in fixed effects, it assumes that it try to control the time invariance. This is the one-line story of this model. Random effects. What random effects will do? Random effects assumes that there is a random variation across entities. Right? I think you know the difference between fixed effect and random effect models. Am I right? So what are the operational procedures of random effects? We assume that the error term, suppose, let me show you this. See, the simple thing is, in the fixed effect model, we assume that there is heterogeneity, which is time invariant. Okay, we accept that there exists a heterogeneity. Right? Random effect model, it assumes that the heterogeneity is purely random. Purely random means it's generated without any factor. Right? So, the basic idea of random effect model is that the heterogeneity which is observed doesn't matter. If it is unobserved, it is purely randomly generated variable. So you know that like we have already one more random thing in our model, which is nothing but the error term. We already have the random variable model. Like that, it assumes that the heterogeneity happens, the group specific indicators or individual specific parameters, unique characteristics of those states are random. It does not have any unique nature. It's time invariant, right? So actually I have to explain this equation. If you look at the earlier equation, I think I asked you to remember one equation, right? What is that? YIT is a function of no constant beta xit plus lambda zt plus u, right? You remember that equation? I asked you to remember. So from where we get these two components? These two components, random effect model assumes that the unobserved factor can be classified into two things. One is a constant alpha, another one is ui, right? This component is nothing but the decomposition of delta z we saw in that equation. That z is unobserved component, right? So you can classify, you can decompose that into two components. One is a constant, that is mu, plus the other one is the error term, right? So this is going to be constant for everything. This alpha is going to be constant for all the states, whereas this ui is generated from random factors. So by assuming in this way, random effect model deals with the problem of heterogeneity. Or getting the point? You will understand. Let me quickly revise it again. We have a problem of heterogeneity. I delivered what is the problem, how we are supposed to manage. How do we model the heterogeneity problem? There are four famous methods for that. One is random pooled OLS regression. What it assumes there is no heterogeneity at all. It's common. Okay, there is no unique characteristic. Everyone is common. All are same, right? So if that is the case, obviously the results are going to be wrong only because biased or inconsistent because there is heterogeneity. Okay. So what about the second model, fixed effect model? How fixed effect model accepted? It assumes it's try to capture the heterogeneity through different methods. It's try to deal the heterogeneity. It's try to exclude the heterogeneity through time variant method and first difference method as well as LSDV method. LSDV is not that popular because if you want to deal with LSDV, you have to include as much as dummy variables as possible. It will affect your degrees of freedom. So that is not permissible. So fixed effect model accept that is heterogeneity and try to deal with it. What about random effect model? Random effect model random effect model assumes that yes, there is heterogeneity, but that heterogeneity is random invariant. What is random? Random does not have any logic. It may be anything. So if something which is unique is influencing your character, that must be captured. If something random, okay, right? If I ask you a question in the classroom, this classroom, you may answer well, right? Because you are bound to answer, right? Suppose if I ask you the question when you have food, when I ask you the question in the bus stand, whether you answer it or not. Obviously, no. Why? There is no any bound, right? The answer, whether you are answering me or not, is all purely based on random things, right? So it is not a unique thing. So that's what this model assumes. If you have what is that? Unobserved heterogeneity, it is purely random. So how can you capture that? In the initial model, we have a variable, something called as delta zi. The zi is nothing but your unobserved heterogeneity. We can decompose that into two things. One is this alpha, which is also called as mu. What is term? This is constant. This alpha is going to be constant for all the states, whereas this ui is going to be random variable. So through this model, there is no any specific indicators, right? So here, if you look at the random effect model capture both time varying and time invariant variables. It will capture both. This variable is time invariant, right? It is not going to be changed. It's going to be constant for all. There is no I or T. It is going to be constant. Whereas this I, which is nothing but time variant. It will keep on. This is time variant. IT is changing. This is capture both time invariant as variant heterogeneity, right? But if you want to estimate this model, you need strong assumptions. But generally, if you want to deal with the heterogeneity problem, people prefer only fixed effect model or random effect model because you have to make such a strong assumptions about your data set. Then only you can do it. The question is, how do we check?
UI is only cross-sectional varying, right? UI doesn't have.
So that's what I'm going to see. The random effect UI is a group-specific random element. It's for a group. Each group we have a random element. It is not time invariant. Like unique character, this is unique character, but it is random. That is a character. You are answering my question. Not you are not supposed to answer. It depends upon the situation. It's random. You may answer or may not be answer also. Right? It's a cross-sectional unit. That's what I'm saying. UI is a group-specific random element.
What is time varying here in UI?
Oh, the time invariant estimate of the both of time varying and time invariant. This variables are time varying, right? HI, we have a vector. This variable are time invariant. It captures both. That's what I gave in K in that equation. I think this equation is very tough. That's what I copied. These things are in elaborated explanation. Maybe if you require, I can show you this thing. But getting the point. This is the point. It's a random effects model capture both time varying and time invariant effects. What are the time invariant effects? This constant is time invariant. It's not going to change with respect to time. Okay. What is time varying? This X is nothing but the dependent variable. We have I and T. It will change with respect to time and with respect to individual units also. What am I supposed to?
So
No. I am not even finished half of the thing.
okay. So after T, there will be.
Maybe I can finish this part. Once we come back, we can discuss about the rest. I have one more topic in the second half also. I don't know how much time I'm having. Too much of things. Fine, or can I rush up? Although it's a small thing, if you take up something, take up is very important. Sure. Or can I go a little faster?
Yes.
A little faster you could.
Go by minority.
With this.
Random parameters. What is random parameters? As of now, we assume that only there is a time varying observed things on your alpha, right? The heterogeneity. But here, your random parameters assume that even the parameters, okay, that X will use to change with respect to time. For getting the point. See, the coefficients of the recursive are same across all the units. But here, what happened is that beta, right? This beta. This beta, if you estimate, see, if you whatever regression coefficients you are going to estimate, you will get only one beta, right? Whether the panel data model or a thing, it's going to be one beta. But this random parameters will give you different betas for each and every cross-section unit. But initially, we assume only the constant will change, right? But here we are assuming that beta, that parameters also used to change. What are the parameters here? We're estimating constant as well as the intercept, alpha and beta, right? Initially, we assume that alpha is time varying, alpha is unique. This random parameters model will assume that not only that alpha is time varying, the parameters used to change. Look at this model. What happened here is beta I is also time varying. This UI is also time varying. That is the point. Okay. Yeah. As of now, we talk about only as of now whatever we discuss. Among these four models, the most prominent and famous models are fixed effect and random effects. Generally, if you have the problem of heterogeneity, the best model is fixed effect model. Only random effect model won't support you because you have to go with strong assumptions. Okay, that's the first thing. As I told you, how do we decide about this? It all depends upon your need, your data structure, your observation. Better you can try both the models. Okay, sometimes you can try. I think you know what are the tests we are using to check whether fixed effects or random effects or Hausman specification test. Based on that, if you check Hausman specification, it says something wrong. Then you check both. Then you decide. Okay. Two individual effects. As of now, let me show the slides, then I can. We are able to understand the difference here. As of now, we assume that there is a heterogeneity from the cross section. Exactly, you got the point. Whereas in the 2F factor, we may have heterogeneity with respect to time also. Unique characteristics. That's what we assume, right? Heterogeneity only in the cross-sectional unit. Whereas in the 2F individual models, we may have response heterogeneity maybe with respect to time also. The best example is take the consumption pattern of individuals before COVID and after COVID. Right? Forgetting the point. So here what happened is the time is also heterogeneous. It's keep on changing. So generally we have one-way individual effects model and two-way effects model. We can apply this model for all the four things. Food OLS, fixed effects, random effects, another thing. I'm not going to show that. It's very hectic. I'm just telling you there are other models are available. So you can ask a question, which one to choose. It all depends upon your need. Depends upon theory. Sometimes you are looking for a special situation. Better you can try all the models. Maybe you pick which one is best. Suppose in theory supports something. You all know that economic research must start from backed up by theories. Okay, what we are doing is we're trying to either prove or disprove the theory, existing theory. Okay, so generally you start with theory. If it says something, then you can go with single way estimated model or. So this is the final part. I think all of you know. How do we decide in fixed effect model and random effect model? Yes, it's based on specification test, right?
What is the theta command for two-way?
Which one? See, comments and all, now everything is open. You just simply, there is a forum called as Estima, ESTMA. Okay. Estima is for data. Actually, you can't post anything, but you can see what are available there. Those comments are available from 80s people are posting there. It may be a little exaggerated, maybe from 25 years of data will be there. Even the forum will be like each and every specific models will be asking. If you want to know a heterogeneous model, there's the forum called heterogeneous model. If you go and see, people might have asked this. Even you can find the command for this thing. Everything is there. You can simply download that and you can execute it.
Spelling.
ESTIMA, Estima. They are the startup providers actually. You can learn this course. Nowadays, all your ChatGPT is giving, but still I have a little suspicion about the codes. Even though you generate codes from ChatGPT, just add one more word. After the course, you ask whether this code is right or wrong. Most of the cases, it say wrong only because I experienced that.
Yes.
Once you get the code, you check with ChatGPT itself whether the course you are giving is right or wrong. Most of the cases, it say wrong because that is my experience. Then I stopped asking codes with ChatGPT. There are a lot of forums out there. You can go with web pages, individual authors might have shared. You can learn things from them wanting. ChatGPT, I don't know. I'm not very sure about this. Okay. So which model, whether two-way individuals or one-way individuals, all depends upon your need. Okay. People have different research purposes. If you have enough time, then you can try all the models. You can report all the models. The other thing is you have to, even though you get results, you need the logical reasons to interpret it. Simply getting numbers is not research, right? System is nothing but the math machine. If you feed anything, even the child can do estimations. Without knowing anything, he or she may click some menus, the result will be generated. The point here only we have an upper hand. We have to know what the result it is, right? So how this thing Hassman specification works, you know, right? I think I don't want to go on this. What are the other alternative models? Maybe after this I can stop. So as of now, we talk about only these 4 models. I told you already, we are talking about a very simple basic panel model. Apart from that, there may be dynamic panel model. I think all of you know about what is the difference between basic model and dynamic panel model. What is the difference?
Lag values.
Exactly.
Time lags.
Time lags. If you include the lag values, the model, then the simple static model becomes dynamic model. So if you have such a variables, then we have some other methods also. I already told you, if you want to learn parallel econometrics, we need some understanding of over time series economics. There is a concept called as instrumental variable method. Right? Instrumental variable method. What you can do is
A very simple question. If we include lag values of dependent variable, then it becomes dynamic. If we include lag values of independent variables also, then also is it dynamic?
yes. See, even the VAR model. Let me give an explanation from time series. In the VAR model, if you include only the lagged values of the independent variable, then it becomes simply AR model. Okay. If you're including the lagged values of other variables, that is also possible. You can include the variable which is not even in the model itself. That become VAR XMA model. It has become dynamic only. It depends upon the need. Sometimes it all depends upon the logic. Suppose you are checking about the consumption. Consumption not only depends upon your today's income, it's also based on yesterday's income. You're supposed to do that. Okay. But if you are including both dependent and independent variables, the setup will change. Interpretation, you must be very cautious. The entire, as I told you, inclusion of exclusion of one single variable in the model will affect your entire results, all the parameters. You must be very cautious about that. Unless until see, there is something called as parsimonious model. You have learned this term in time series. Minimum number of variables as much as possible. In VAR model, you can go till 64 things also. 64 into 3, it may be any numbers. But the good quality of model is parsimonious. Means that you have to include as minimum variable as possible. Then only you can get the condition of things on. So instrumental variable, you know what is instrumental variable? suppose you have the problem of endogeneity. What is the endogeneity problem? Sorry, heterogeneity problem. Heterogeneity is something which has a unique characteristics, which is affecting your decision making. So you have to identify a variable which is closely associated with this variable, but which is not affecting your endogeneity. Not only endogenous variable or dependent variable through the error term. Error term is a channel. Okay, whatever happened here, it will affect the error term because the error term will affect your dependent variable. So you have to identify a variable called instrumental variable. Identifying instruments is a little tough. That's what people used to do. You can take the lagged values of it. Okay. There may be some instruments. Suppose if you want me to give an example, income and wealth may be it's not an exact instrument, but still, instead of using income, you can use wealth. Okay. What is the condition of instruments? If you correlate these two variables, those variables must have high correlation, but it must have the least correlation with the dependent variable. If that is the case, you can pick that as instruments. That's one way. Second thing is dynamic panel models. As I told you, I'm talking only about simple panel data. So dynamic panel models, you can include what is that? Ladder values of other things and other dynamic factors also. So why we are supposed to talk about heterogeneity? Because of this. As I told you, first point is very important. There is a variable which is influencing your decision making, which is influencing your dependent variable. But you are excluding it means the impact of error term on your dependent variable is going to be high. So estimates what you are going to get is not reliable. It is going to be biased. Okay. So you are going to have something called as variable bias. The first thing is that I told you, but still, I think something else. Second thing is, as I told you, if you have more information as such possible in any research, it will give you the reliable results, right? If you are not very clear about something, you have only these informations, then estimating those things won't get you the better results, right? So if you are incorporating, even though there is heterogeneity, if you try to address it, if you try to incorporate in the model, if you try to remove it from the model, the estimates is going to be more reliable because you are using as much as information as possible, right? In the demand theory, you take an example, if you're including only price and taste and preferences, if you're excluding income, then that's going to be a problem. Taste and preferences also matters. If you include those variables in the model, then it's going to be more reliable, right? Final thing is, if you go for more variables, it will help you to understand more dynamics, the deeper dynamics of the economic relationships. So I stop here. Any questions we can ask next session? Maybe